All right, guys, good day. Hey, this is part two, I guess, in our solubility saga. We're going to do some example problems on solubility. This is about KSP and solubility. Solubility is a limit. It's a maximum amount, okay, that can dissolve. More than that maximum amount causes a precipitate to occur. Its solution become cloudy. Like in this example problem, all right, solubility of lithium carbonate is some value, okay? That'd be the total maximum, largest concentration you could get of lithium carbonate in a solution before it would become cloudy, all right? So the solubility of lithium carbonate is that. What is the KSP? You have to remember that solubility is about dissociation equilibrium. You have a solid, it's going to dissociate into the ions, in this case lithium and carbonate. Do your two lithiums over carbonate. You could do a groovy little ice table, ice table, ice table, ice table. You have none of that, none of that. Kind of make two of that, one of those. So that's 2x, that's x. That's a solid, so don't worry about it. Anyway, you don't really have to do all that because it's always going to be an ionic compound. It's always going to be cation than the anion. So you can just say, hey, the KSP is going to be the cation, not two lithiums, just lithium, the cation squared. There's the two times the carbonate. Okay, and that means the KSP is always going to be whatever this dude is, which would be at 2x because there are two lithiums squared times carbonate. So if you want to find the KSP value, you just need to substitute. KSP is going to be 2 times something squared times that other something, and then you have your KSP value. Our somethings, our solubilities, the color level show up. Solubility is X, whenever that in the last video. Solubility is concentration at maximum concentration. So it's always X, because it's not the solubility of lithium, it's the solubility of lithium carbonate. Okay, and so for every lithium carbonate X, you get twice lithium, so it's going to be twice that number. 7.4 times 10 to the negative 3. Carbonate's on a 1-to-1 ratio, so it's just 7.4 times 10 to the negative 3. So basically you have, if I can do my math, 0.0074 squared times 4, because it's 2 squared, times 0.0074, and we get 1.6, I'm counting right, 1.6 times 10 to the negative 6. Okay? That's all it is. Basically, given a KSP, solve for X, the solubility, or in this case, given the solubility, solve for KSP. A harder question. This is a former AP question from years ago. You have a beaker. It contains calcium and barium. Okay. And basically, to that beaker, you're going to add fluoride. Most fluoride salts are soluble, but there are some exceptions, and calcium and barium are two exceptions. Okay. You're going to add fluoride, and one of these is going to precipitate first, one of them precipitate second. Okay, and you have to realize that, hey, this is what's going on. We're going to have calcium fluoride is in equilibrium with calcium and fluoride. Barium fluoride is in equilibrium with barium and fluoride. Now, the easy way to look at this is to say, hey, look, if KSP represents the solubility, okay, the KSP here is 3.5 times 10 to the negative 11th. The KSP for barium is much bigger at 1.8 times 10 to the negative 6th. Okay, which one is more soluble? The barium fluoride. Okay, which one's less soluble? The calcium fluoride. Okay, so why? Because it's a smaller KSP. Bigger KSP. KSP tells you how soluble it is. Smaller is less, bigger is more. So calcium fluoride being less soluble is going to precipitate first. And so what you would write on your AP test is it precipitates first because it has a smaller KSP. But I think that's kind of a crappy explanation in a way. Some of you guys are going to want to see the math. And so let's look at those KSP expressions. This is KSP is going to equal calcium times fluoride squared. This is going to be KSP is barium times fluoride squared. Now we know their KSP values, 3.5 times 10 to the negative 11th. Now this KSP value, 1.8 times 10 to the negative 6. And we know the concentration of calcium and the concentration of barium. That was given in the problem. You might have ignored it. 0.01 molar. So why don't we substitute that in? Okay. This is 0.01 times some concentration of fluoride squared. Okay. This is 0.01 times some concentration of fluoride squared. So this is some value, which is going to be 3.5 times 10 to the negative 9. Okay, this is going to be 1.8 times 10 to the negative 4th. So you can sort of see once you take a square root that this is going to have, this is a smaller max concentration of fluoride. So you have to understand these concentrations are the maximum concentrations that you can have, the solubility, how much can dissolve. Okay, we're not talking about one atom dissolving. We're saying, well, what's the maximum number of atoms that can dissolve? Well, for calcium fluoride, it's going to be a smaller number. For here, it's going to be a bigger. Okay, so if we go way back up to my little pictogram, all right, come up yonder to this groovy little thing, okay, if we add fluoride in, calcium is going to bind up with the fluoride, barium is going to hook up with the fluoride, you know, and as the concentration of fluoride builds and starts at 0 and slowly builds up, it's going to reach the calcium level first before it reaches the barium level. Okay, because here, all right, so as we go here from 0 fluoride, okay, we're going to have to go to a concentration of 3.5. Oh, screw that. We're going to take that to a concentration of 0.1, 2, 3, 4, 5, 6, 7, 8 to that, from 0 to that. Here we need to go from 0 up to 0.00, well, square root of that, but whatever, 0.18, and then square root of that, but that doesn't really matter. All right, this is going to take less drops. Okay, this is going to take more drops. I don't know how many drops that's going to be. It doesn't really matter. Because if you're dropping in drop, this is going to get cloudy. Well, the whole thing's going to get cloudy first. But as soon as you reach this level, it's going to get cloudy. And this level of fluoride isn't enough to precipitate over here. Remember, don't panic about this. Okay, the main thing that you got to take home is that smaller KSPs precipitate first because they have a less soluble. All right. On that AP test was a follow-up question, and all they really wanted was, you know, it was like 2 points. 1 point to say the calcium fluoride was going to precipitate first, and 1 point because it has a smaller KSP. Okay, so smaller solubilities would precipitate first. Should just make sense. Things that are less soluble are going to fall out of solution first. The follow-up question to it was this one. calculate that minimum concentration of fluoride, okay, to initiate the precipitation. So for that, you would say, hey, the KSP would equal the concentration of calcium multiplied by the concentration of fluoride squared. Again, it's not 2F1 negative, it's just like with the lithium, it's just the square, okay? In this case, we get our 6.7 times 10 to the negative 11th. It's going to equal 0.01 that was given in the problem. I'm going to pretend that's two sig figs, even though it wasn't. Concentration of fluoride squared. If you do that, you get 6.7 negative 9 to the square root. You get 8. At least I did. 3, 4, 5, 8. I have the right number there. 3.5 times 10 to the negative 11th. I hate when I mess up. Yeah, you guys probably raising your hand and I'm telling me that I messed up. Appreciate that, man. I really do. 3.5 times 10 to the negative 11th. So it's 3.5. No issues here, guys. Negative 9 to the 0.5 is 5.9. 5.9 times 10 to the negative 5th. That would be your concentration of fluoride. Something you might get confused on is you might be saying, hey, when I did this before, when we put those x's in, 3.5 times 10 to the negative 11th, this was x, this was 2x. So do I have to put a 2 in there for the fluoride and like divide everything by 2? And the answer is no. We're not asking for the molar solubility of the calcium fluoride, okay? Calcium fluoride is, that concentration of calcium fluoride is X. The concentration of calcium would be X. The concentration of fluoride would be 2X. But that's not what we're talking about. We're not saying, hey, what is the solubility of the fluoride in calcium fluoride? We're not saying that. We're saying, hey, if the KSP is this, all right, and calcium was this, what would be the concentration of the fluoride? All right. So since we're solving for the concentration of fluoride, we're going to solve the KSP expression, the screwed little expression for the concentration of the fluoride. No X, no solubilities. Ready? So I hope that made a little bit of sense. That problem, last two should have been a little bit more difficult, particularly that second one. Something like this scribble up in here. These things should be easier. Given a KSP expression, solve for something in there. Solubilities are X, KSP is KSP. Anyway, I hope this helps. Send me your emails as always. Love you. See ya.